Welcome to Study Loop.
First, let's figure out our change in kinetic energy, or our change in energy of the system. It starts with a kinetic energy, call it kinetic energy initial, equal to 1/2 m v naught squared. Because it comes to rest at some point after compressing the spring, we'll say that the final kinetic energy is just going to be 0. So our change in kinetic energy is equal to negative 1/2 m v naught squared. And to solve for the displacement, well, we just set that change equal to negative kx. So for springs in series, our effective spring constant is just going to be equal to k1 plus k2. So plugging that in for k up above and solving for x, we find that the answer is m v naught squared over 2 times k1 plus k2. Okay. Now, in parallel, it's a little bit different because the effective spring constant is equal to 1 over k1 plus 1 over k2. So when we solve for x in this case, the answer is actually 1/2 m v naught squared times 1 over k1 plus 1 over k2.